Hello there, this is Leo Waldup for Kit Guru, and this is Simon Lambden of Intel. He's going to talk us through the new Intel Skylake for mobile, so that's laptops and convertibles, I believe.
Yes, that's right.
Lovely,
yeah.
so we're looking at mobile rather than desktop.
Okay, so for my user experience hat and the job I do at Intel, 6th gen processors, as we call them, Skylake, as Leo just mentioned, is the code name for them. These really are very innovative devices and really have allowed the OEMs to sort of, I suppose, really bring great battery life, great performance, and a whole range of devices to market. So I have some examples here, and would like to share them with you. So here we go. Here is the Yoga 900. So
That's Lenovo.
that's Lenovo, yes. It was released yesterday, I believe, at a launch event. Thin and light, okay, so there was a version of this that came out last year of a Core M processor, but the main difference between this and the previous gen is this actually supports a Core i7, so this actually uses the 15 watt processor, so in the same form factor. Again, really delivering much more performance than the previous generation, but in the same form factor. So again, something that the 6th generation processor can really actually deliver, and you know, users will sort of see the benefit of this. And if I can
Just to butt in, as you only got one hand, is that
Yes,
a flip back
it is
and
a
do
flip
that?
back,
Lovely.
yeah.
And is that touchscreen?
it is a touchscreen
Now,
as well.
did we check earlier? That's a bizarre resolution screen, slightly sub 4K.
It's 3200 by 1800, I believe.
Right.
Is the screen resolution.
And then touchscreen, obviously, when it's converted, because and keyboard locks out in the usual style.
Exactly.
And approximate weight of that? He says, shaking it vigorously.
That's a good question.
Okay, I mean, I can feel it's thin and light. Obviously, because it's the convertible, so you've still got the keyboard attached. It's not pure tablet, but hold it up to camera, thin.
It is definitely thin.
And we'll take photos for Kit Guru.
Exactly. I think it's around the 1 kilo mark.
Certainly feels that way, right?
Yeah.
Okay, now what we have here is the Dell XPS 13. We covered this recently at a launch, and there's a little bit of confusion about whether the 13 and 15 were DDR3 or DDR4. The XPS 13 is actually DDR3, the 15 is DDR4. Simon's going to tell us more about this.
Yeah, sure. So the XPS 13 uses our dual-core processor. So it's part of the U family. So the letter at the end of a processor is quite an important differentiator between the devices. So this particular model uses an i7 or i5, depending on how you buy it. The i7 would be a 6500U and the i5 a 6200U processor. But both of those processors only support DDR3 at 1867, so that's the speed it's working. DDR3L, by the way, for low power mode. And this is just part of the design of the product. And you know, there's no configuration option you can have to change it to DDR4. The XPS 15, however, uses the quad-core processor. So this is part of the HQ family, and this is a differentiator, and this is more akin to the desktop 6th gen processors that were launched back in August. And this has DDR4 capability, as well as a separate chipset.
Okay, now with the DDR4, presumably that it's more bandwidth for more cores, you can understand that. And Dell was talking about when they had access to high density chips, they were going to bump up the memory, I recall, from 16 gig to 32 gig. Presumably DDR3L, on the other hand, I'm guessing that's now hit a plateau and we're not expecting any higher densities there.
That's correct.
Right,
yes.
okay, fine.
Yeah.
Lovely. So Dell XPS 13, we've done the run through this. We're hoping like crazy we can get a review of this soon. Anything else to tell us about this, or should we move on to the next model?
Well, again, it's super thin, super light. Like the other XPS in the family that you may have seen already on Kit Guru, it has a super thin bezel, which is a really cool thing.
Essentially, it's one form factor smaller than the screen size, is pretty much the way they're selling it.
Exactly. And I think that's a super innovative, way of you're getting a bigger screen into a smaller chassis, if you like.
Yes, quite, and aluminium and carbon and such like.
Exactly.
No, looking forward to that. Although I must confess, the one that really tickles my fancy is the 15, purely because of the Gruntier processor, more memory. But
exactly, we actually have a 15 here as well. But
yes, indeed, yes, quite.
And as Leah just said, it has a quad-core processor, discrete graphics as well, and a 4K screen.
Now, you were telling me earlier, specifically with video decoding being done in hardware, have you actually reached the stage where video playback uses no more power than running at idle, or is it very close to it indeed?
It's very close. So one of the aims of the Intel engineers is always, one of the things they say is, no, we try and make video. So, why do you care about long battery life? Let's say when you're unable to connect to a plug socket. Let's say you're on a train or a plane, or in another place without able to get any power. What you're doing. Maybe looking at some emails. You might be doing a bit of surfing if you've got, say, a 3G connection or a 4G connection or something. But the other thing you're probably going to do is watch videos, right? And these devices really lend themselves to this whole entertainment experience. Excellent screens. A lot of them now are IPS or PLS panels, so they're like superb color quality, excellent viewing angles. Again, this is something that the PC is really sort of. The innovation by the market has really demanded this sort of quality of panels and display, and the PC industry has responded. So you now get excellent displays on these devices. 1080p is almost the minimum now, and then we get 4K is becoming more and more common. So you want to watch your videos, right? And it's a great device to do that on. But the idea is that you're going to be sat there for a little while watching a video.
Hopefully about 2.5 hours, you'd think.
Well, yeah, maybe. And maybe want to watch a whole bunch of them, right? If you're on a transatlantic flight, 9 hours, 11 hours, just sat there. So the idea is that we're trying to make the video decode done in the actual hardware. So there's something called a QuickSync engine, which is actually part of a processor. It's part of a video engine, so it's part of the Intel graphics. And this will actually do the decode, so do the video decode actually in hardware and really sip power, just use a tiny amount of power.
And just to butt in again, and to clarify, you're telling me that where you have a system on chip and everything is in the one piece of silicon, the video decoder is in there. Yes. When you have a processor and chipset, as certain models do, where is the video decoder then?
The video decoder, again, is inside the Intel processor part of the chip, so it's in the big bit, if you like, which contains the Intel graphics. So wherever the Intel graphics is, which would be part of a processor now, as of the second generation core processor, this is always done inside that processor. So this is done on the 40 nanometer process, so it's the new transistors, if you like, and absolutely it's optimized for power.
Excellent. Simon's now going to tell us about the RealSense cameras, which I foolishly thought were akin to Microsoft Kinect, but he's telling me kind of, but no. And he's now going to tell me how they're different and what it actually does.
Exactly. So there's actually two RealSense cameras on the market right now. The first one being the F200 camera, which has been around for about a year and is really going to be much more common with the 6th generation core devices. And this one is, as Leo said, works a little bit like the Kinect. However, it's somewhat shrunk for several reasons. One is so it can fit inside a laptop bezel. So if you think about how wide a laptop bezel is, it's not very wide.
In this bezel here,
yeah.
we've got how many actual things?
So this is the other camera, which I'll get to in a second. So this is the R200 camera, but the F200 camera would have 3 devices in it. So you've got an optical camera, so that's a 1080p webcam effectively, and then you've got an infrared camera that just sees an infrared, and then you've got an infrared projector. And that's a really clever bit, because that's the bit that Intel shrunk to actually get inside a bezel. So this device essentially paints a pattern on anything in front of it up to a meter away, and the infrared camera can see the pattern and work out the distortion. And then from that distortion pattern, we can work out the shape of the object, whether it's human, whether it's a face or a hand. And this is really where the RealSense camera very much differs away from the Kinect analogy that you started off this piece with, because we're talking about finer grain detail of hand, and then we can measure fingers, and we can measure joints of fingers, or we can measure face, we can measure eyes, we can measure a smile, grin, whatever. And so we can see these features, and really to get the user control that we want for a PC experience, personal computer experience, we need that level of control. But the camera only works between a range of say 20 centimeters and a meter. So it's not designed to be working a long way away from the screen. But you think about it, how do you use a PC? You're sat in front of it, right? So that's why it's a logical thing to do. So that's the F200 camera. The R200 camera that's in this device is brand new. Okay, so this is something that we're bringing. Most of the OEMs have decided to couple it with the Core M processor. So this is the second generation Core M processor based on the same Skylake architecture that the other devices we talked about here today have. And this camera here is a world-facing camera, so it looks away from the user and can see the environment the user sees. Now, the really cool thing about it is it actually has two infrared cameras, so it's sort of got stereoscopic vision as well as a laser projector, so you get a really fine detailed image of what's going on in the world. And it has the optical camera as well, so it can overlay the textures and the colors and all the other stuff you'd expect on top of the object, so you can actually make optically correct looking objects, in real objects turned into the virtual world effectively. Now,
being blunt about it, you're allying this with Skylake because it's happening at 6th gen, because it's now. Is there actually anything about the camera, had the camera existed last year, would there be any reason why you couldn't have allied it to, I was going to say 5th gen, 4th, whichever, the previous gen? Or is there actually something specific about 6th gen, or is it because it's now and 6th gen is now, therefore they come together now?
Actually, it is, that's a very good question. It is about the processor. It's about the sheer processing power needed to handle all this data. So not only have you got this optical data coming in, which, you take for granted now, most things can handle that. A few years ago, you stuck a webcam on something, it was like a slideshow, right? So now, of course, we've got enough performance and you don't think anything of a webcam. But now you've got this three-dimensional data. So you're overlaying that 3D data on top of that webcam data, or the other way around. That's a lot of data. And so you need a lot of CPU performance to actually process that data. And this is where this comes in. So yeah, there's some hardware offload actually in the camera itself, which again is
interesting you should say that. I read a thing the other week to do with the Sony DSLR and to do with the business of profiles, where it recognises if you've got people or food or pets or whatever. And there was a strong suggestion that Sony wasn't actually saying that the camera essentially had a limited degree of intelligence. It was like infrared detectors in a home security system. They recognise the difference in a dog and a cat because they know they've got a certain number of scenarios they're likely to face. So it can go, rather than recognise everything from scratch, it's baked in. That's a cat, that's a dog, that's a bird, that's something else. This obviously is working within a defined set of parameters. He says certain distance you expect people to be doing certain things. How much actual intelligence have you got in the camera, if any, or is it sending all the data off to be processed, or is it handling stuff in the camera?
To be sure, I'm not absolutely sure, so right. I won't talk authoritatively about that. What I do know is we've produced a whole SDK, which is software, which requires a processor to do the work. So, there would be some handoff between the device. So obviously, we've designed them to work together.
Yes.
So, as you would expect, but as for the intricacies of exactly how it works, that's a good question. We'll have to refer that one back to the guys who...
And I'm assuming you're only going to... realistically, you now own the mobile market, AMD being blessed in nowhere. So... obviously, we're only going to see these cameras allied to an Intel processor. Theoretically, is it possible to see this package with a different processor, or is it only going to be Intel stuff throughout?
Well, it connects via USB 3 interface, but again, the software is optimized to work on Intel processors because it's Intel software.
Indeed.
So the whole package was designed by Intel. It's not been brought in from somebody else. No. It's The software, the hardware is all Intel proprietary technology.
Interesting.
Okay.
And then there's this virtual green screen technology.
Yeah, sure. So that again allies itself back to the other camera, and if you think about that logically, about knowing how far away something is, that allows the camera to identify what is behind the user,
Right.
and then
Take
not
it
bother
away.
showing it.
Understood,
Yeah, so
understood.
exactly.
Which is very much a visual thing, so let's see if we can visualize that.
One other comment about this device. So I showed a two-in-one that was a convertible earlier,
Yes.
so it converts. So that was what we refer to as tablet first.
Yes.
And this device, which is a Core M, is basically that was laptop first. So this is tablet first. So this is basically a tablet, but with a keyboard that attaches to
Right.
it.
If I pull, is this going to come apart?
Yeah, it's magnetic, so it just comes apart, just like that. See?
And I noticed actually it's HP, and that says Bang & Olufsen down the side, which is...
So that's a new
switch.
partnership. But,
I wasn't aware of that. I'm seeing it for the first time live. Excellent. So what do you want to tell us about that?
So Core M, this enables this super thin, light, and this is way under a kilo. So I would say it's,
this I'm holding here, this is purely keyboard and
that's
touchpad
purely
and a
keyboard.
connector.
Yeah,
Right.
exactly. And the reason that's a little bit more weighty than say some of the others you may have seen is it actually has a metal cover which stops it flexing. So some of the problems you may find if you're an avid typer with some of these sort of more detachable keyboards is they flex quite a lot, and it might be a little bit uncomfortable to type, whereas this is quite rigid. It does have a little bit of weight to it, but it's
Spectre, yes,
it's
the Bond.
well, it's called the Spectre X2. So this is its model name.
Understood.
Okay, so hence the Spectre branding on it.
Okay, Simon's going to show us the virtual green screen technology that you can use with RealSense, which is a Skypey changing the background of where you are type of thing. But he can demonstrate it far better than I can explain it.
Fair enough. Good intro. Okay, so here's an example. This is a brand new IdeaPower 500 camera, 500 laptop, okay, with the RealSense F200 camera built in.
Which actually you can see far better on this than you could previously, because you can see the individual components, and they are what?
So this is an optical 1080p webcam. This is the infrared camera, so this actually receives the infrared signals which are projected via this. This is a little laser projector, okay, and this actually paints the laser picture on whatever's in front of the camera, and then this receives it.
Now we have our entirely willing subjects pictured here over there with the same laptop.
That's right. It's an identical
so using
laptop,
the same technology.
and this is a Skype call, okay, and using a plugin from a company called Personify, which is one of the partners who've made a plugin for Skype which makes use of the Intel RealSense camera. So it's effectively a virtual camera driver, and what it does is it allows the background to be removed. So you see Claire on her holidays in a London warehouse for some reason, but anyway, and let's say we go to the office. So Claire, if you want to go to the office, so now it's actually removed the background behind Claire and stuck in another picture. So now she's in the conference room, still on the deck chair, but hey, this is really showing, okay, no green screen needed, and it's actually using the RealSense camera to understand how far away she is from the user is away from the camera, and remove everything behind them. So it's using a combination of face recognition to recognize it's a human being, as well as the depth recognition to remove everything behind the user.
And just for a laugh, if we change to a different background.
Yeah, so maybe you want to go into space, or take it somewhere you're picking. There you go, see. So yeah, and this is as simple as that, and it's instantaneous because it's all happening within the camera. There's no lag, there's no pre-rendering needed. It just happens in real time.
And if we just go back to the real world, as it were, here's the background. And there we are, back in London. Lovely, thank you very much.
Thanks.
Thank you, Claire.